Now then, we've moving on now to the fourth lesson in geometric sequences and series. So in our first one, we recognised a geometric sequence and stated its common ratio. That was r. Remember, one term divided by the previous term gives you the value r. It's what you multiply the first term to get the next term. You multiply it by again to get the next term, and so on. Then we looked at calculating the nth term of the geometric sequence, and from that we arose at this formula down here, un equals ar to the n minus 1, where a is the first term, r is the common ratio, n is the term number. We then looked at solving problems involving growth and decay, so basically interest and depreciation. In today's lesson we're going to be finding the sum of a geometric series. Okay, and this is where we're going to arrive at this formula down here, Sn equals a brackets 1 minus r to the n over 1 minus r. So we will derive this and show you how this works. Okay. Now, first of all, we need to know what the formula is. Now, you don't need to know how to prove this, but it's quite a nice one to show how we prove. So, if we look at this, well, basically what we're trying to find is the sum of the first n terms. Now that is a plus a times r plus a times r squared plus a times r cubed, okay, all the way up to a times r to the n minus 1. Now, if we take this and multiply it, I don't know, by r, let's say. So if we do r times Sn, now you may think that's just a bit bizarre doing that, but you'll see something happen. The first term becomes ar, the second term becomes ar squared, the next term becomes ar cubed. You notice how it's repeating itself. Okay, we get this situation where this term here is the same as that term there. Okay, so little things are happening which are going to be quite convenient. Okay, and hopefully it will show us how we do it. So that's the same as that, that's the same as that, that's the same as that. And this is the case all the way up to the very last term. But in fact, the very last term, this one, gets multiplied. So the one before will be a times r to the n minus 1, but we'll also get a times r to the n. Because when we've multiplied that by r, we'll get a to the r to the n. Okay, the previous term, a to the r, a r to the n minus 2 will become a r to the n minus 1. Now, we're going to do one of those things we do in maths every now and then, and I'm going to say, well, let's delete. Let's do the first one and take away the second. So we're going to calculate Sn minus r, lots of Sn. So in fact, all we're left with is the first term, a, and the last term, because every other term will cancel each other out. So we're left with that. So Sn minus r Sn equals a minus r to the n. Well, now we don't actually want to know what Sn minus r Sn is. So if we factorise this, if we take out that, we've got 1 minus r here. And also at the same time over here, we could factorise this. We've got a minus 1a brackets 1 minus r to the n here. Oh, that should be a bracket there, not an equal sign. Okay. So in fact, when we divide, we get Sn equals a brackets 1 minus r to the n over 1 minus r. And this is, if we look here, this rule here. Okay. Similarly, if we change the order of 1 minus r to the n and make it rn minus 1, we also change the order at the bottom, it's still the same. So in fact, there's two versions of this. Doesn't matter which one you use, each one will give you exactly the same solution. So what we're going to be doing is number crunching with this then to solve problems. Okay, so here's an example of this type of question. Now, if we look at the first one here, a, we can see straight away that a equals 2, the first term is 2. R, the common ratio, is 3, because you're doing 2 times 3 is 6, times 3 is 18, times 3 is 54. And we're given that n is 10. So we're substituting into the equation, well, S10 equals a, brackets, 1 minus r to the n over 1 minus r. It doesn't matter which version you use, I'm using this version right now. So all we're simply doing is number crunching this. So 2 brackets 1 minus 3 raised to the power of 10, close brackets, over 1 minus 3, and we'll get the answer, 59,048. Now you notice I've used this one. In the book they use the other version, so 2 brackets 3 to the 10 minus 1 over 3 minus 1. It doesn't matter which version you use, you'll get the same solution. In the second question, the first thing is we don't know what value n is. We know, to start off with, that a is 1024. We also know that r, the common ratio, is not just a half, okay, but it's actually a negative a half, because it's going positive, negative, positive, negative, positive, negative. Now, let's think about this carefully. So we know the nth term is 1, okay, so that means that 1024 times 1/2 to the n equals 1. So dividing by 24 will give us this, but we can also change this to a positive power, can't we? So we've got n minus 1 there, sorry. So in fact what we could do, multiply by this, we actually get 2 to the n minus 1 is 1024. So taking logs of both sides and bringing down, so we get n minus 1 log 2 equals log 1024, and then dividing and then adding 1 on, you'll find that this equals 11, n equals 11, just by number crunching. So we know our value of n, we know our a, we know our r. So S11 is going to be equal to 1024 brackets 1 minus, and this is negative a half to the 11 over 1 minus negative a half. Again, just number crunching on your calculator. 1024 brackets 1 minus brackets fraction negative 1 over 2, close brackets raised to the power of 11, big close brackets all over 1, take away, and in brackets negative 1 over 2. So be really careful and make sure you type it in correctly into your calculator. Okay, we get the value 683. So the sum of the first terms, or those terms, is 683. Now, here's a more typical question, one you'll get in your exams. Let's read this carefully. It says he invests £2,000 on January the 1st every year, and he gets 4% each year interest on that amount. And the interest is calculated on the 31st of December. How much is there in the account at the end of the 10th year? So think about this. Year 1, he's got, at the end of year 1, the £2,000 he's paid in, which is multiplied by 1.04. After the second year, so at the start of the second year, he's got that plus £2,000. So that's start of year 2. The next year, he's got 2,000 times 1.04 squared plus 2,000 times 1.04 plus 2,000. Now, it's at the end of the 10th year. We've got to think of this. So at the end of year 10, he will have 2,000 times 1.04 to the 10 plus 2,000 times 1.04 to the 9 plus 2,000 times 1.04 to the 8, and so on down to 2,000 plus times 1.04. Okay? So, if we think about this, in this case, we are going to get, our value for A is going to be 2,000 times 1.04. Okay? The common ratio is going to be 1.04, and N is going to be 10. So, it becomes 2,000 times 1.04 brackets 1.04 to the 10 minus 1 all over 1.04 minus 1. Which again is just a simple number crunching thing. Make sure you use your calculator effectively. So 2000 times 1.04, open brackets, 1.04 raised to the power of 10 minus 1 all over 1.04 minus 1. And when we number crunch that, we get a long answer, but it starts 24,972.7028 So, as ever with money, we're going to round this to 2 decimal places. So it becomes £24,972.70. Okay. Next. So in this question, we're after the least value of n, where this calculation, okay, exceeds 2 million. So we first of all need to think, well, in this case, A is 1, R is 2, because it goes 1, 2, 4, 8, the rate common ratio is 2. So Sn is going to be 1 lot of 2 to the n minus 1 over 2 minus 1. Notice I'm using it this version, and in this case we want to find the value of n where this exceeds 2 million. So straight away you'll realise we're just going to have a calculation. Logs are going to come up in this. Okay, this bottom bit here is simply 1. So in fact we've got 2 to the n minus 1 is greater than 2 million. That's the calculation we're working out. So we add 1 onto both sides. 2 to the n is greater than 2 million and 1. So taking logs of both sides, bringing the power down, so we get n log 2 is greater than log 2 million and 1. So n is greater than log 2 million and 1 over log 2, which if we calculate, so fraction log 2 million and 1 over log 2 gives us a value of 20.9310. So this is 20.9. Therefore, n, if it has to be greater than that, n must be 21. N must be, that's the first value where it exceeds 2 million. Okay, so in this question you'll notice we're using the sigma notation, meaning sum of. So in this case we look at the little expression we're given here, and it tells us to find the sum of all the values where we substitute in r is 1 up to 10. So in that case we're going to be working out the sum of 3 times 2 to the 1, 3 times 2 squared, 3 times 2 to the 3, 3 times 2 to the 4, up to 3 times 2 to the 10. Okay, now that means in this case that r equals 3 times 2 to the 1, which is 6. It also tells us, because the bit we're multiplying every time is the 2, that our common ratio is 2 and that our value of n is 10. So S10 is defined as a brackets r to the n, 2 to the n minus 1 over 2 minus 1, which we just number crunch, and if you type this into your calculator you should get the answer 6,138. So it's a nice simple question. Don't get fooled by the sigma notation. It's well worth practicing using that. So please remember, as you go on to do the examples, that there are 2 versions of the equation. The first one, 1 minus r, and the second one where they're both switched over. Okay, so we get r to the n minus 1 over r minus 1. So examples when you use the second version is when you have a value of r greater than 1. Okay, in that case you'll find that this is positive, this is positive. If we put it into this version where r is greater than 1, you'll find that this becomes negative, this becomes negative. It's not a problem when you're doing it on the calculator, it's just a bit untidy. If r, on the other hand, is less than 1, in other case it's fractional or negative, you may find using the first version easier. Okay, but again, it doesn't matter, both versions will give you the correct solution. So you should be ready now to go on and have a look at exercise 7D. As you go on to this, please remember to challenge yourself and look at questions 2 to 9. They are more the style you'll get in the exams. Good luck.